I'm Kenji Saito. So, first of all, thank you very much for giving me this opportunity to present at APSIG. This is my first time at APSIG, and I've been all excited about it. So, I'll give a lecture on a world with blockchain and blockchain governance. And this is self-introduction. I'm Kenji Saito, and I'm a senior researcher at Keio University, Keio Research Institute at SFC, which is a Shonan Futsal campus, situated in Futsal City, Kanagawa Prefecture, in Japan. And also, I'm a lecturer there. I teach a class called Beyond Blockchain. Last year it was called Blockchain, just blockchain, but this year it's called Beyond Blockchain, and I teach that class at Faculty of Environment and Information Studies at the same campus. And also, I'm a representative director of a nonprofit called Beyond Blockchain, and also Chief Science Officer at Blockchain Hub, which is an incubation organization that brings up many blockchain startups. And also, I'm an organizer for children's camps. And my research includes P2P, peer-to-peer networking, and digital currency. I started the research from year 2000. And I received a PhD doing that research in 2006 from Keio University. And after that, Bitcoin appeared, and I've been asked a lot about it. So I ended up being a specialist on the blockchain. And also, I've been holding this academic camp for children in Fukushima since year 2011. If you know, that's the year of the Great East Japan earthquake, tsunami, and the nuclear disaster. And the Fukushima Prefecture is the very place which there is this nuclear power plant. And I've been organizing the camp with my friends. And in my mind, these activities are connected. The P2P and digital currency and internet and society research and the academic camp all are connected in my mind, because I'm thinking of how we could design the society for the future. And in that future environment, children today will be the main characters of the society. So let me start with this IBM news release in December last year. I just read through it. It's called Blockchains and the Supply Chains. And Walmart, JD.com, IBM, and Tsinghua University launched a Blockchain Food Safety Alliance in China. And the four companies will work together to create a standards-based method of collecting data about the origin, safety, and authenticity of food using blockchain technology. IBM is a blockchain technology provider, one of the blockchain technology providers, to provide real-time traceability throughout the supply chain. This will encourage accountability and give suppliers, regulators, and consumers greater insight and transparency into how food is handled from the farms to consumers. This has traditionally been challenging due to complex and fragmented data sharing systems that are often paper-based and can be error-prone. And my first impression to this release is really, because blockchain technology has lots of problems, and if all the technological problems are solved, blockchain alone cannot realize this, I think. So let me start with sort of a definition of a blockchain, or what it can do, or what it has been said that it can do. What does a blockchain try to provide? One, save and maintain records whose content and existence nobody can deny. I separated content and existence because technology used to achieve these different content. For content, digital signature would suffice, but existence of a record, any record with a digital signature can be deleted without affecting the digital signature itself. So it cannot be solved by the digital signature alone, where this blockchain technology come to. So and to satisfactorily achieve number one, we need number two. Everyone can confirm that one is working correctly. It has to be everyone. involved, because if there's this particular authority who can confirm that one is working, then that authority can deny the record, or content or the existence of the record. So it has to be everyone that is involved. And 3, for the same reason, nobody can stop 1 or 2. Because if someone can stop, then that denies the whole thing. So if these 3, number 1 is the most important, and number 2 and 3 follows. And if these 3 are achieved, then we can virtually fix records in the air without any particular support, or everybody supports that record. And there are twofold problems. I think in my original PDF, it's better. It says twofold problems, and it is really it is really realized. It's a technological problem. The blockchain today is very imperfect, so there will be a problem of timeliness. I will talk deeper about it later. Timeliness, scalability, dependability, adaptability, and sustainability. And if these technological problems are solved, so if it is really realized, there are still a problem. Can it be applied to real problems? For example, for the supply chain, food supply chain, how do we link firmly between the physical entity, the food, and its digital counterpart? We can, identify for example, tomato, a single tomato with a number. We can put a number in it, on it, like put a sticker on the tomato itself, or the bag, or the case. But we can change we can just peel off the sticker and put another one or something like that. So it's rather difficult to firmly link between the physical entity and its digital counterpart. And can we trace materials after being processed in supply chains? Like if it is a tomato, maybe we can trace where the tomato goes. But when it is processed and became a ketchup, then what kind of link between the tomato which is the origin of the ketchup, and the ketchup which is generated from the tomato? How do we link? It has to be some procedure which is how can I say it? It cannot be solved by technology alone. It's how this procedure is operated and how we can make sure that it's correctly done, or something like that. So it will be always the so-called socio-technical or techno-political issues of how technology is in action, how it is operated. So it's not a technological problem alone. And let me further explain what the blockchain is. And I think we should start with the Bitcoin, which is the origin of the blockchains, where the concept of blockchain is first invented. So any technology is an answer to a question which is in a society, and otherwise the technology is not in use in a society. So I think we should first think about the question that Bitcoin tried to answer. And since Satoshi Nakamoto, which is a pseudonym for the developer of the Bitcoin, we don't know his or her or their identity, so we cannot ask Satoshi what the question was. But instead, we think about the question from the technology itself by reading the code and making research on how it works. Then we got this problem. So the Bitcoin problem, it tries to answer, maybe, how do I let nobody stop me from spending my own money? So it's about economic freedom. And this, I think, it's in Asia. It's in Asia in general. I think we can understand this is a problem because, for example, in India, they stopped using 2 paper bills. The prime minister announced it in late in the evening, and on that day, that day was the last day of the 2 paper bills can be used. So in 4 hours or so, it's unusable. So at least they have to bring the banknotes to the banks, and it's the freedom is lost. And so this is about distrust against central bank money, which is controlled by central bank and other banks. And Satoshi probably thought about giving people freedom to spend their own money without any interference. How successful it is in question, actually. So the answer that Bitcoin provides, the first answer is really easy. So there shouldn't be any intermediate party, because if there is one, like if this digital currency is a web service, then if the service stops, then we cannot spend any money on it. So it has to be P2P, peer-to-peer, without centric management system. So exchange digital coins in a P2P manner without fixed servers. That's an answer, but we need digital signatures too, because we have to make certain that the person who has the right to do so is spending money. So using digital signature to guarantee validity and non-repudiation of the content of the transaction. But this is not the whole answer, because if, suppose Alice and there's Alice and Bob and Carol. And Alice wants to spend 100 bahts to Bob and send the digital coin to Bob with her digital signature. But being digital, it's only that the Bob has the copy of the digital coin with Alice's signature, and Alice still keeps her coin, which is supposed to be not spendable. But Alice decides to spend it, and Alice put the same digital signature on it and send it to Carol. Then Bob thinks that he received a coin that was Alice's possession, and the coin has the digital signature of Alice, so he has received a valid coin. And Carol thinks that she received the digital coin with Alice's signature, and that was once in Alice's possession, so she thinks it's a valid coin. But Alice spent the 100 bahts digital coin as 200 bahts coin, so it's unfair. So this is the double spending problem. And any designer of digital currency must solve this problem. The easiest way to do it is to use a server, single central server, but it's not applicable. And I have another solution, but in Bitcoin's case, it's a really easy solution, which is print an evidence of transaction on a newspaper. Then the Carols can say that if she is going to receive Alice's digital coin, she sent Alice's digital coin, then Carol says that it's on the newspaper that you spent this particular digital coin sending it to Bob, so I cannot receive that coin because everyone knows that the correct owner of that coin is now Bob, so I cannot receive it. So that seems to be an answer, but we cannot use the newspaper itself because it has a central management system, the newspaper company. So if newspaper company decides not to print that article on the paper, or the newspaper itself discontinues, then Bob or Carol cannot spend that coin anymore. So we cannot really put it on a newspaper, but we create an illusion of a newspaper by everyone's effort in a P2P manner. To create a newspaper in a P2P manner, which is the origin of a blockchain. So Satoshi, him or her or themselves, says that in the original paper. So it's an alternative to the newspaper. So blockchain, like I said, it fixes records in the air, but in Bitcoin's case, it fixes promises in the air, because money is a form of promise that if like Alice sent coins to Bob, then Bob can send it to another person if he can provide the proof that he is certainly the Bob himself. It's a promise. So using the blockchain, you can fix promises in there. And also, another point is that money is a public good. It can never be really privately owned, because I don't know if it would depend on the each country's laws. In Japan, it is illegal to burn coins. I think it's similar in many countries. If it is really a private position, private goods, then it can be burned by the owner, but it cannot be. It's a public good, and public goods whose control moving people to people. Thank you. So there may be an anticipation that for any private goods, this kind of technology can be applied, like library books, or the rental cycles, and things like that, or the property like lands or houses. There is an anticipation that this kind of technology can be used. And then let me explain how Bitcoin works, which is where the concept of blockchain originated, using a physical model. And it's called a beaker and a newspaper model. Like I said, blockchain is alternative to the newspaper. And the coin can be expressed in the form of beaker with liquid in it, because it deals with quantity. So suppose that there is 21 million cubic centimeter of liquid in a tank. It's 21 million cc, and since Bitcoin's unit is BTC, it sounds somewhat similar. And anyone can have as many beakers as they want, and each can measure down to 10 to the power of minus 8 cc. This is like science fiction, but just believe it. And these beakers are not held by each person, but these beakers are placed in a public space. And the public space is a representation of a storage in a blockchain. And each beaker is locked by a mechanical lid, opened only with the participant's private key. So it's by using the digital signature. It's a metaphor of digital signature and a private key and digital signature. If one makes the digital signature, only then the lid can be opened and the liquid can be transferred to another beaker. So today, a selected party can take 12.5 cc of liquid from the tank. This is like mining, and the reward of mining is 12.5 cc today, 12.5 BTC today. And who can be selected? To be fair, it's okay. Let's make a lottery, but we cannot use a normal lottery in a sense that there is a box, one single box with lots of tickets in it, and there's only one winning ticket there. And we decide on the order, according to which the participant draws the ticket, and only one of them will win. And then that person can go to the tank and pour the 12.5 cc of the liquid. But this shouldn't work. Why? Because someone draws a winning ticket, and 12.5 cc. If it is Bitcoin, it's a lot of amount of money. So he or she is very excited, and he or she is so excited they got a heart attack and dies there. Then nobody goes to the tank to pour the 12.5 cc of liquid. So the whole system stops, and everything is denied. So this cannot be used as a solution. So we use a special kind of lottery in which every participant has a box, and there is one single winning ticket in there, and it's the same amount of tickets. And because the box is transparent, we can make certain that everyone is doing the same thing. And when draws, they have to be blindfolded and draws and look at if they won the ticket or something like that, and they continue to do that, then if someone draws a winning ticket and got so excited they got a heart attack and stops, but somebody else will win the ticket eventually, so the system never stops. So by doing this, it can satisfy liveness, which says that the system never does not stop and the system proceeds, but with some counter effect. One of the counter effects is that the faster they draw, more advantageous. So it's the competition of drawing fast. That's exactly what's happening in Bitcoin blockchain. Sorry, the number 2 of the model. So the liquid can be moved among beakers in certain ways. The first thing is that only the corresponding private key can open a lid. And if it is really mechanical, you can make certain, but this is digital, so digital signature has to be verified by someone. And once opened, the beaker must be emptied because the whole system it tries to solve the problem of double spending. So we have to make sure that the quantity is spent or quantity is not spent. We have to distinguish clearly between the two states, and the easiest way to do that is to, if you use it, then the quantity is emptied, and it can be said that this beaker or the representation of a coin is used. So these two are important things, and this defines the validity of a transaction, and it has to be guaranteed by someone. Who guarantees that? The selected party who got the 12.5 cc of the liquid, the miner, the winning miner. And that participant validates the trace and creates a new page of a newspaper with the records of transactions. And each record is digitally signed by the spender. So it's like a signed article by the spender themselves. And the first article happens to be that that selected party poured 12.5 cc of liquid to his beaker, or her beaker. That's the first article. And that person, the person who got the winning ticket can also take spill. It is supposed to empty. They're supposed to empty the beaker, but some kind of spill is left, and that's the transaction fee, and it can be defined by the spender themselves, and the validator can also take that too. But there's another problem of the this lottery mechanism that I explained. Another counter effect. It's since the process is autonomous, if one thinks that he or she drew a winning ticket, there may be some other person who think they draw the winning ticket. And they may not know about each other because this is a P2P network connected in an arbitrary way, so that they don't know about each other, and they produce the different page of a newspaper with the same number, same page number, and they have to be different because the first article is different. The article which says this person got the 12.5 cc, and the article that person took the 12.5 cc, so the page is necessarily different, and these are broadcast, meaning they are passed and copied and passed and copied to fill the whole network. And then people have two different copies of the same page number. What do we do about that? We have to decide on which page is the correct one. And we cannot prepare a single authority to decide because of the reason I've been explaining. So everyone has to decide by their own. So actually the series of pages may get separated. There can be a split of sequence of pages. So which one is the correct one? The intuitive explanation is that longer one wins, so that the pages are observable. So if one realizes that there are longer page sequence than one have, then they can switch to the longer one. That's how the consensus on uniqueness of transaction works, because the different set of page sequences can have sometimes have the contradicting transactions. So often people lose their private keys. That happens. Then, oh, sorry. I'm sorry. I put a long button. How do I? Thank you. So let's consider this as a currency. This is Bitcoin. And people may think that, oh, this is how the cryptocurrency is different from real money, and why this is virtual, because this is considered as currency and not real currency. But this view is, I think, wrong, because any currency is considered as currency. It's not a physical entity or physical phenomenon. If it is a physical phenomenon, it has to be global. But for example, a restaurant in this building doesn't take US dollar for payment. So it's different in, among communities, or shall I say, it's more psychological than physical. So in my mind, the Bitcoin, Japanese yen, US dollar, they're all equal as a currency. But in each jurisdiction, they have a different set of laws. So in Japan, Bitcoin is a so-called virtual currency and different from Japanese yen. But that's how people decide. So let me explain one thing about how this is protected from falsifying. Because if this page is protected from falsifying, this is not believable as a correct record. So there is this mechanism called hash chain with proof of work. The hash chain itself can be falsified. Hash chain just says that this page's digest must be included in the next pages and next page, and this page's digest must be included in the following page. But this can be changed easily, quite easily. If one change, each article here is a transaction record, and each transaction record is protected by the digital signature, so it can be altered without compromising digital signature. So we can just eliminate that probability, but one can remove the article itself from the page or block. Then, one can deny the transaction really happened, but if it happens, the content of this page is different. So through cryptographic hash function, we obtain the digest, and the digest is different from the previous one, before the alteration. Then this page's content is different now, so they have to change the digest in the following block. But this is easy. If there is 1 million pages or blocks, perhaps we can, with your computers, perhaps we can alter the whole thing within a minute or something. So this is not how the protection is made. The protection is made with proof of work, connected with hash chain, this structure. The digest of this page cannot be any number, but must be equal to or below a certain target. The target number is typically inherited from the previous block or recalculated in blockchain, in Bitcoin's case, every 2016 blocks. Then the problem, the target is very low. Like the cryptographic hash function used here in Bitcoin is a double SHA 256 hash function. So it produces 2 to the power of 256 range of numbers. Let's pretend that the floor here is 0, represents 0, and the ceiling is the 2 to the power of 256. Then the target is, I have to mind the video. The target is just below the sole of my shoes, or very close to the floor itself. So any alteration happens on this page can produce digest here, 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 and never really, in an easy sense, can reach the target. So it's difficult. So if one alters here, it takes a tremendous amount of time to alter this, receive the right digest with altering this place called nonce, number used once. It can be any number, any random number, and the attacker changes the number and tries many times and receive the digest equal or below the target, and then they have to rewrite this value, and then this page is altered, so they have to do the same thing. So what I've said is that cryptographic digest of page must be less than or equal to the given target value for the page. And since people can't guess what digest is returned when the data is how modified, it must be repetitively tried for many, many times. And this is the lottery that I explained. And with this lottery, no record can be altered unless the same amount of cost, same amount of drawing the lottery tickets paid. So it's difficult. It's said to be difficult to alter. That's how the Bitcoin blockchain is protected. And also about the consensus, we call it Nakamoto consensus because it's not really a consensus. The Nakamoto consensus says that the sequence of pages with the highest accumulated cost of proof of work, the drawing lottery tickets, is the correct history. Because that history is the most difficult to alter because any sequence of pages has to be paid with the same amount of cost when it is created if they want to alter it. So it's very, how can I say? It's conforming to the design that Satoshi wanted to design a system where nobody can deny the existing records, and they can achieve that by this Nakamoto consensus to some extent. Because in this figure, this one is the correct history because there are, if these have the same target, then they are longer the chain is, the more cost is paid to create it. But if someone decides to invest on this sequence, then they can surpass the correct one. So this sequence is now the correct one. It can be altered, so it's not perfect. So let me say from up to now I've talked about Bitcoin, but there are lots of different blockchain technology, and there are like blockchains with about the same principle that I've explained, and other distributed ledgers. And in blockchain, the blockchain is the most famous, and it is designed to transfer Bitcoin, the cryptocurrency. But today they have an open access protocol in which they can define arbitrary set of quantities that can be transferred using the Bitcoin blockchain. So they can write applications on Bitcoin blockchain. And Ethereum is, from the beginning, designed to enable application development. But it's very experimental, using lots of technology, trying to use lots of technologies that are not verified yet. So Enterprise Ethereum Alliance is formed by many different, lots of companies, and they are working on the standardization of the technology. And there are other distributed ledgers, And the most famous one is Hyperledger's series of private ledgers. It's hosted by Linux Foundation, and Hyperledger is a governance body, not a name of a software today. And the most famous one is probably the Fabric, which is the first original code was provided by IBM and Digital Asset Holdings. Their codes are merged, and now they are called Fabric. They are all open source. And Intel provided the initial code for Sawtooth, another ledger. And Swarm, it's a Japanese startup, and who provided the original source code for Iroha, another ledger. And R3 consortium is a consortium of financial institutes, and they're building a ledger called Goda. And IOTA is IoT micropayment system, and they have a ledger called Tango. And I am a representative director of a nonprofit called Beyond Blockchain. We are developing BPC1, the Beyond Blockchain 1. But for these ledgers, we must ask that can nobody really deny the content of existence of a record, or can everybody really confirm the correctness of the above? Because there are problems. And let me introduce the problems of blockchain and other ledgers. And these are problems of blockchains. And that can be easily solved if we design another new ledger from scratch. But the blockchain has a lack of timeliness because it has a probabilistic behavior. It's in Bitcoin's case, it's one block in 10 minutes in average, right? So it's not exactly with a 10-minute interval, but it can be like 3 minutes, 1 minute, or 1 hour, something like that. So it's not assured to work timely. And lack of confidentiality is that since it's verifiable by anyone, it's really open. So there are technology to try to hide the content of a transaction, but basically verifiability is open to everyone, so there's a lack of confidentiality. And oneness, this is like distributedness versus replication, and blockchain is actually really a replication technique rather than distribution, because every single node does the same thing. Then it cannot scale because the performance is limited by each participating node's capability instead of the sum of the participants' capabilities. So there's a lack of scalability, and also there's a governance problem because we cannot change the specification of a blockchain easily because everyone must be doing the same thing. And it really happened last year when the Bitcoin Cash split it from Bitcoin because, as a consequence of many years of discussion of block size. Today we have a 1 megabyte limitation for the blockchain, Bitcoin blockchain's block size, but it is a problem for scalability. So some people thought that enlarging the block size may partially solve the problem, and maybe that's true. But there are different opinions, and if blockchain is a normal internet application technology, then what would happen is that we try the larger block size in this region, and if it works, then anybody is free to adopt that. That's how the internet application technology evolved, but we cannot do that with blockchain because every miner has to be doing the same thing. And if in some region they decided to enlarge the block size to 2 megabytes, then the other miners don't approve that. So there may be a different sequence of history. So it has to be splitted. That's how the governance has a problem with blockchain. And also there is a problem of incentive mismatch because the security of blockchain is supported by the market price of the native tokens. In Bitcoin's case, it's BTC, and in Ethereum's case, it's Ether. So when the price drops, the many miners have to leave, and then the security level will be lowered. And these can be solvable if people redesign ledgers from scratch, like we try to do that. But many distributed ledgers are not designed from scratch and have lots of problems. And I think we should be skipping this. And this is blockchain versus private ledgers. So blockchain is designed to promote tamper resistance, verifiability, fault tolerance, and these things. But it lacks the consistency, resource saving, latency, and things like that. But the private ledgers designed to improve the blockchain cannot actually be verifiable or something like that. So it's really has been a trade-off. But we've been trying to solve that problem. But we can talk about it later if you want. And this shouldn't be believable because we've just finished version 1 of Beyond Blockchain 1, and we are in the process of evaluating. This is just our hope that it works this way. So there are some references. So on tamper resistance, well, everybody says that the blockchain is tamper resistant, but it's a software system. So a software system is never tamper resistant to begin with. So it's a matter of is tampering detected and when. And previously, access control has been used for existing databases, and tampering is detected with journals or logs. But if the journal or log is altered, then the alteration is not detectable. And what blockchain introduces is that relation among data is enforced, so that simple tampering would cause contradictions within the set of data. But it can detect tampering if a contradiction remains, but it cannot detect tampering if no contradiction remains. So let me explain this table. This is a comparison between Bitcoin as a transferring mechanism for Bitcoin as a currency, and Bitcoin as a foundation of application. Ethereum, it's a foundation of application, and many private ledgers, and what we are working on. So there is a cost of tampering, C, and the value on that platform, V. And if C is greater or equal to V, then there is no rational reason to pay that cost to destroy or alter the system, because what's the point? But and for the Bitcoin, original Bitcoin's case, this condition is satisfied, considered satisfied, because it is maintained by miners, the lottery drawers, and they pay the electricity cost, but their expected gain is higher than the paid electricity. That's the whole reason they are doing the mining. And if the profit is high, then there are lots of new miners joining in the system, and then the difficulty is automatically adjusted so that there should be more cost. So they approach the price, the value of the Bitcoin. And if the price is lower than the electricity, then lots of miners would leave. Then the difficulty is automatically adjusted, so it's easier and less electricity, so it approaches the price itself. So in theory, the Bitcoin's price and the paid electricity cost form an equilibrium. So this condition is somewhat satisfied. But for other applications, there may be more value than the whole Bitcoin handled over the Bitcoin blockchain. Then this condition is not really satisfied. So it's not protected any longer. There will be a rational reason to pay the cost to alter the blockchain to gain more value. That's what it says. And interesting governing issue. Let me just explain this. I think this is important because this is an internet governance school. So the problem Bitcoin tries to answer and other blockchains to follow is, like I said, how do I let nobody stop me from spending my own money? And it's about freedom. But this is the source of the cause or the reason of the many incidents happening on the blockchain and the cryptocurrency. Suppose some technology solve this, then I must be authenticated by my own. Because nobody should be able to stop it. It's not like bank money, where you have bank card and you know the PIN number, then you are yourself, but that is authenticated by the bank. So the bank decides to stop it, then it can be stopped. To prevent it from happening, one must prove that one is exactly that one by that one's ability itself. So they use a digital signature, which means that if they have a private key, valid private key, then that's that very person authenticated as that. And everyone must be able to trace transfers, because if there's some certain entity who can, trace transfers, then that one can, stop the system. So everyone must be able to trace transfers. And nobody may get the transferred money back. If it happens, it's a denial of the payment. So have you heard of Mt. Gox, coin check, or other cases of stolen coins in which private key is illegally used? So everybody can trace where the money went, but nobody can really get the money back. That's exactly how it is designed. It comes from the design of the blockchain. But there's another problem. So if a platform chooses to deny the incident, what happens? It happened in Ethereum. In Ethereum, there's this incident that the Ether was stolen, lots of Ether was stolen, and that particular transaction in the correct history, so-called correct history of Ethereum, never happened because platform decided that this never happened. This is a bad thing. It never happened, and split it, a new history, before the incident happened. So, if it happens without the court order, by the platform's own decision, is it platform taking some juridical role? It's one governance question. So cyber-physical society and cybernetics, it's about keeping records. So let me just introduce this. AI may be Byzantine. Byzantine in computer science distributed systems terminology is that there can be arbitrary failures, including betrayal or any deviation from the protocol, and AI may be capable of doing that. Then it may be meaningful to save and maintain records that even AIs cannot alter, and there may be a reason to think about this technology like blockchain, which I think blockchain is imperfect, but there may be improvements. So at the conclusions, any technology is an answer to the specific question in society. So we need to question what to question first, and I think that was the right way to do that. And we didn't really talk about cybernetically organized society, but we've been talking about it actually. So we've been discussing about AIs and their effects and how AI can be governance. That's exactly what I wonder, and it cannot be solved by technology alone. So it's always the governance issues. Thank you very much.
Many thanks, Doctor. Very interesting and very informative. I have two questions. Many investing in Bitcoin or any cryptocurrencies for the first time, they found there is a cost. Do you think there is an environmental cost? Since the whole process, I think it needs very complex algorithms to run and a very huge amount of computing power. This is the first question. Second question, since it is a peer-to-peer network, if there is any way to prevent or block the money laundering to be transferred by using the blockchain? Thank you.
Thank you. They're both important questions. And the first question about the environmental effect on the of the proof of work. The proof of work itself is not really complicated. It's a simple task repeated for many times, so it takes a huge amount of electricity. And since the blockchain is blockchain based on proof of work is protected by the cost of proof of work, if malicious party decides to suppose this is the cost cast in the today's proof of work based blockchain, and if malicious party decides to cast the same amount of cost on top of it, then that one can be able to alter the history, so it's bad. So what's happening in Bitcoin blockchain is that the cost is exponentially growing, so it is very difficult to double by malicious party, but it's actually doubling. So that's the, I think, fundamental inherent problem of proof of work, and it needs to be solved somehow. And in the beyond blockchain case that I've been working, we don't have proof of work, or we don't have block, or the similar validation mechanism, but we think that the protection for falsification can be made in a different way than protecting by the cost. It's called intercrossing references that in that environment, each application is operated in separate domains and with separate parties, and they're sometimes related but sometimes unrelated, and we try to exchange the digest of transaction between unrelated domains so that it will be difficult to alter everything, because it means that to illegally enter the many different unrelated domains. And that's, I think, one of the ways of making protections without causing environmental effects. And the second question of money laundering, it's also fundamental if we decided to make a system with where nobody can stop spending money. So I think it's inherent, but the practical solution against that is that today we have to exchange cryptocurrency to some fiat money in order to spend. So exchange has to be monitored. That's been done in many different countries as a fight against money laundering. But it's always a trade-off between economic freedom and the control. So I think the problem would remain. That's my answer.
Thank you.
I'm Dr. Govind from India. My question is, like the way you made a nice presentation based on Bitcoin and blockchain. I'm wondering whether you could have separated the Bitcoin and Ethereum, only talked about the blockchain. Blockchain technology.
Yeah.
Directly without going into the Bitcoins.
Mm-hmm.
Because what I mean to say is that if blockchain technology we had to explain in itself, without any, some generic examples could have been given without the Bitcoin. What I mean to say that most of the issues which you have brought it out, like governance issues and the third-party verifiability in the central banking systems and the hash function and all. So whether it makes blockchain more complicated or makes it more easier? That is my question is.
I don't really think I understand the question, but are you asking that what
I mean to say is whether these issues which are popping up in the blockchain technology, whether it gives more confidence to the public in the going into the blockchain, or it is moving away from the blockchain.
Oh, I see. Bitcoin is too big to be changed rapidly. So let's talk about Ethereum, which is changing rapidly. And they are trying to solve blockchain's problem that I explained, for example, that these problems in the as an extension of blockchain, like timeliness, they have a mechanism called Casper, which enables the finalization of transactions, which is never possible in the prior blockchains because it's probabilistic. But they decide to using a proof of stake voting mechanism. They decide to finalize the set of transactions. So that's one of the things they are working on. And lack of confidentiality, Ethereum has introduced the zero knowledge proof on the transaction so that the transaction can be verified by not knowing the content of the transaction. And openness, they have oneness. They have, for lack of scalability, they are working on sharding, like normal distribution of the processing. They're working on that. And the governance problem, they have layered blockchains so that each blockchain can be governed by different policies. And also, for the governance problem, Ethereum is governed by Vitalik Buterin, the inventor of Ethereum, so it's easier for them to change things because everybody listens to Vitalik. And for incentive mismatch, they have the whole idea is that they want to learn application, and to run the application, they have to pay. People have to pay some amount of ether, which is translated into a concept called gas. But it's basically it's an ether. So anyone who wants to run applications keep purchasing ether so that the price of ether never drops. But I think it's too naive. So because it's price of ether is actually more controlled by the speculation, so that it may be suddenly drop. So they are doing great. I mean, they're experimenting on things, but I think, in my opinion, the more correct way is to move, separately from the original design of blockchain.
Thank you.
Hi, my name is Teddy Mantoro. I'm from Indonesia. I have two basic quick questions by you. Number one is we have deep web and dark web, and sometimes that's happening a lot of illegal transaction. My question is how we can trace that kind of illegal transaction. Is number one. Number two, if the government, for example, they tries to take a tax for the certain transaction, what is your idea for the kind of problem? Thank you.
Thank you. I think they two are related, and it's how a government can have a control on how the transactions in blockchain work. And I think, like I said, it's a trade-off between the controllability and the freedom of economy. And I think it's a fundamentally different problem. Yeah, difficult problem. But another way of thinking about it is that if we abandon blockchain or make more usable digital currency technology, for example, what's happening in China is that Alipay and the WeChat Pay are so usable so that maybe there is no need for cryptocurrency after all, but it's controllable. So instead of so sometimes the technology can give people a sense of freedom to use or spend, but it's actually controlled by the centric management system, and that's one way that government would want to do. Personally, I dislike the idea, but it can happen. So the one solution is that to provide more usable technology so that people get more interested in that as a payment method. But since today's cryptocurrency is more like investment product than payment method, maybe it doesn't really apply. But that's what I've been thinking.
Good morning, Professor. I'm Santosh from Nepal. My question is how the blockchain technology can be used by the governments to tackle the development problems. Are there any examples the governments have been using blockchain technology? I was thinking from public governance perspective, for example, referendums or elections or large set of data throughout the country, economic survey. Are there examples how they have been using and how the countries in developing regions the governments can utilize the blockchain technology?
Thank you. That's a very interesting question. And since the blockchain technology is about record keeping and it's providing the verifiability to public, then it sounds really suitable for many governmental functionality. So I think there is a possibility. But in my opinion, governments shouldn't use blockchain because blockchain as an external working platform, because government needs to provide sustainability of the society, and but the blockchain is operated by its own and it can be stopped at any time. And people say that blockchain is unstoppable, but for many reasons that, like I've explained, there is a possibility that it stops somehow. Then it's not good for a government to use such a technology. So I think what the government should do is to operate blockchain-like technology by their own. Then they don't need to use proof of work or things like that. So there shouldn't be any large environmental effect, but use the cryptographic hash function and things like that, Merkle hash tree, something like that, that are used in Bitcoin blockchain, and they apply that to a system of record keeping in the government so that they can provide verifiability to the public so that people can trust what governments are doing. And I think that's happening in Estonia before the rise of blockchain.
So can there be a kind of blockchain technology having some kind of control from one end, from the government side, having some kind of control, but open to the other ends?
Well, it doesn't have to be a blockchain, but yes, the government can provide the record keeping, and then they provide the root of a hash tree, which is a hash value that 256-bit value in some kind of government's publication that are shared among public, so that it cannot be easily altered, and they can people can use that value to verify what government's providing is correct. Like this documentation is never altered or something like that.
Hi, I'm Satish Babu, and I've been working with Bitcoin since 2013 March, and currently I'm leading a team developing applications on Hyperledger Fabric and Sawtooth Lake. My question is regarding the definition of Bitcoin governance. I see two aspects of the governance as far as cryptos are concerned. One has to do with the development and planning of a particular product. For example, there's a community around Ethereum that decides what are the priorities for the next releases, moving to Casper and Proof of Stake and so on. So that process is managed by the community, and that is seen as governance of that Bitcoin platform. The other governance has to do with nation states and governments and how they perceive this whole thing, especially blockchain and cryptocurrencies is entirely different things. In India, for example, crypto is banned, blockchain is welcomed. So when you define the concept of cryptography or blockchain governance, what does one really mean? Is it the first thing of the platform being managed by the community around it, or is it to do with nation states and how they perceive Bitcoin versus cryptocurrencies? And because, as you mentioned, Estonia has welcomed this sort of a thing, even before the formal announcement of Bitcoin and so on. Other countries have also launched or have announced their plans. So when we here talk about governance, what is it that we're talking about?
Thank you. When I talked about the governance problem on this slide, I think I've been talking about the technological governance within the community. So how the technological advance is made and that is difficult because of the blockchain being the record of one single history, and of course there's another issue of how government or the association of governments must be dealing with the kind of technology, and that's a separate issue, and I think it's really open for discussion.
So in that case, it's a follow-up. If you take internet governance, there are global processes, for example, IGF. But for the blockchain, although it is seen as very important by many people, there is no global process where these things are discussed, at least where there's an open process where governments can participate, civil society can participate, industry can participate. There is no such thing. Do you see that as a gap, or is it something that will naturally evolve?
Well, I think the technology itself has, this characteristic that is not suitable for internet-style governance, because it's one single entity thing. So the one body manages everything. It's how original blockchain started, and in our efforts in the beyond the blockchain, we have we see the whole system as a interconnection between the different domains, and this is more suitable, I think, for internet-style governance, because we have independence within the domain, so it's really close to internet. So if we want to make, if we see the internet governance is reference to the technology governance of the world, then maybe we should design the technology itself suitable to that kind of governance. And blockchain, I think, is failing to do that. But it's not a failure, maybe, because to the view of the developers, because they are doing what they want.
Me, Romkant Pandit from Nepal. My question is it possible to Bitcoin or any other type of cryptocurrency equivalent to central bank money? If it is possible, then most of the government, Bitcoin is the illegal parts. Is it possible to compromise this Bitcoin and other type of cryptocurrency equivalent to the central bank money? Is it possible?
Well, I think all central banks existing on Earth is considering of or making research on cryptocurrency, and if they can, how they can digitize their design of fiat currency system. Like Bank of Japan, for example, has publicly announced that they are investigating on blockchain technology, but they would never digitize the Japanese yen in near future, because if they do, Bitcoin is not usable as a fiat currency, but let's pretend if it is, then suppose how it can be used. We have smartphones, and there's a wallet software application, and anything we ever want to do with Japanese yen can be done through that application. Then what's the role of the existing banks in Japan? I think that's the Bank of Japan is afraid of, so that they cannot announce that they are moving toward digitalization of the Japanese yen, because that would destroy the whole financial industry. So there is a difficulty. Bank of England is trying to do the same thing with a different approach. They define the role of existing banks as a validator of transactions. So there may be a possibility of doing that. But in any case, every central bank, as I know, is making a research. And the reason behind that is that it's closely related with tax collection, and also the enforcing the finance policy. It will become much easier if the currency is digitized.
My second question is, in the cryptocurrency or Bitcoin, there are different type of threats like malware, bottleneck, social worms, like that type of worms. What type of technology ensure this malware It's not attack in this Bitcoin Bitcoin mining process and other type of process. Is there any specific technology to protect this, or only digital signature is sufficient to protect from the malware?
Malware.
Yeah.
I think it's independent from the design of the record keeping system. So I think really it's independent. There has to be using the existing techniques. The systems has to be protected, and many people misunderstand that the Bitcoin blockchain, for example, is protected because they are distributed. So there are lots of nodes, so that if one node is compromised, they can't compromise all the nodes. But it's not true, actually. If one can be successful in making the non-contradicting change to a blockchain stored locally in one node, then it's broadcast, and then everyone sees that it has a new correct history. So it's not a protection. So I think to answer your question, it's more difficult or more important to prevent from malware and using the existing technique to protect the Bitcoin or other blockchain nodes.
Thank you.
Good morning. My name is Calvin from Indonesia. I have 2 or maybe 3 questions. First is about the cryptography, which is used by the blockchain. As you know, that the cryptography has collision. So what happened to the private key if there is a hash collision between one user to another user? Second question is about is there any way to make one algorithm? For example, currently the algorithm is SHA2, and then maybe because the researcher found the hash collision, they want to change to the other algorithm. Is it compatible or not? And third is how many nodes minimum records to validate the transaction? Okay. The first and second questions are, I think, related, and that's a problem of Bitcoin and Ethereum and many other blockchain technology. They are hard coding their cryptocurrency parameters. They use I think they both use elliptic curve cryptography with particular parameters, and that parameters are hard coded in the code, so they can be changed even when they discover that it's compromised. So I think for newer technology, like beyond blockchain 1, we have this field that tells which particular cryptography is used in this transaction or something like that, and also the interconnected references that I talked about can be a protection for the compromise and the evolution of the cryptography, because we can freeze the past transaction with a new technology by making the newer cryptographic hash function to make a digest of existing transactions. That's another way of thinking about it. And what was the third question? The second question is there any way to make a first algorithm can cooperate with the second algorithm in the same information of the blockchain?
So it's the same thing. So today's many blockchain technology cannot cope with such evolution, but I think when they decided to use a different set of parameters, then they maybe they change the data structure so they can partially cope with it. But the way to go, I think, is to put the field explaining which cryptographic functions are used in particular transaction, or even in this part of transaction or something like that.
Okay, the third one is how many nodes need minimum requirement to validate their transaction?
It really depends. So, in Bitcoin, there are less than 10,000 nodes. But many of them are controlled by, if you see a pie graph of a hash rate of a Bitcoin, it's controlled by really big power, a few of them, and lots of small ones. So like 2 or 3 of those big power validates the transaction, then it becomes validated in Bitcoin. So that's because the proof of work can be accumulated, aggregated. There's a problem of aggregation of computing power in certain locations in the Earth, and so that's a problematic. I think there's an effort to make it more distributed.
Thank you.
This is a kind of a question as well as some suggestions. And I think a blockchain, so it's similar. So extended internet governance. So we started thinking about digital society and digital governance because all those technologies are connected. And then, so because we have already experiences in internet governance, so we can make it useful for the extended technologies and then technology-mediated society. So blockchain, this really broader about a question about trust. So blockchain technology is about trust. Whether we can develop or establish an alternative trust. So the trust mainly authorized by nation states nowadays. So sovereign power is based on trust and then power. So from people to the government, it's people give their individual power to government. So government can have sovereign power, and then that power rule the entire population in nation states. And then same thing, so finance or monetary value, that's based on trust too. So it used to be based on rice or even she cells in a hunter-gathering economy, and it became gold or silver, and now it's still gold and silver. It's old form of for proof of trust, and it's still used. And then now we have a currency, so US dollar and then Thai bahts. Those are based on trust. So this Bitcoin and blockchain is actually questioning whether we can develop new trust based on community of technology users. So for example, internet users. So this is very interesting question, and then experiments. But I have some limited understanding, because even though I know in my brain it's a finance, monetary value, money are all based on trust. We have been we have had that money as a number in just my bank account for a long time, but still in actuality, I kind of have a trust, a tangible trust in money. So we need to break it first. So we, now it's very difficult to find the experts in digital economy, but we can look into the history instead, so that we can have a better perspectives, comparative perspectives for the trust. So I think at APSIG next time we may wanna have lecture on the history of money or monetary trust. And also, I think it's a important question in terms of identification. So our government actually prove our identification. In many cases, it's now based on biotechnology, our fingerprint. So the new system of identification, for example, based on blockchain, is a kind of alternative, whether we can prove our identification without giving up our bio information. So.
Well, thank you. I totally agree about the point that looking at the history of money is important. I've been trying to do that myself. And I'll comment to your comments in some ways. Like first of all, the blockchain governance, the people who are governing the blockchain technology has reference to the internet governance. Like Ethereum has standardization documents called ERC. There are a series of standards called ERC because it's Ethereum request for comments, so it's referring to the internet RFC. So they're actually the descendant of internet governance in how they try to govern the technology. But I think there's a better way. I mean they should improve. And another point is that I try to remember. I try to remember the other point. The history of money is important, and right. And yes, the blockchain technology has a possibility of to become a foundation of local community to sustain their society. But unfortunately or fortunately, the Bitcoin technology began as a global currency platform, and it's different from being local. And since the developers of blockchain, Bitcoin blockchain, believed in the global currency, single global currency, they switched trust from central bank to the blockchain, which they think is, based on mathematical proof, but it's not real. It's not really. It's trust to certain way of protocol. It's a trusted protocol, so I think they're like sort of mistaken where the trust lies, and the existing global blockchain technology took trust away from people trying to do that, and actually money has a long history of trying to do so. So it's when we use money, it's trusting money instead of trusting the people who are spending money. Nobody asks in a store who you are, as long as they don't pay by check. So it's even in today's world, it's always this thing between the people trusting people and trusting money itself. And Bitcoin is like extremity of trusting money. So I think the problem of money, Bitcoin is inheriting. So it's not a solution to the problems that money has been causing, and that's my opinion. But the same kind of technology can be used, I think, to make a different kind of economy, because it's what it really does is record keeping and making providing the verifiability to public. So that's usable. That's usable to make a different kind of economy. For example, based on energy instead of trust. I mean, instead of trusting central bank or government, like joule or watt, the unit of power or energy can be used as an accounting measure for what we do. That's another possibility, I think. And that can be sustained by blockchain-like technology, but probably without proof of work, because it would be contradicting. But I think it's technologically possible. So the question is how we use that technology and its possibility to build a better society. It's a broad question and goal, but that's what I think. That's my comments.
Okay, coffee break. Picture. Kyle, would you like to announce? 10,000 year concerning